4C. Okay. We want to plot this function. How do you plot this function? Okay.
Which number is that?
4C. Graph let me see something. Can you see there? Yeah? G of x equals to natural log 2x plus 3. Okay. How do we do this? How do we do this? All right, I'll make it simple. Can you take away this 2? Okay? How do you do this one now? Now it's better, right? It's just log, natural log. It should be the same shape as natural log x with a shift, right? Because this has impact on the x direction. The x direction is horizontal or vertical? Horizontal, right? Because you add 3, so this new x, the new value, new x value, needs to be 3 less to compensate, right? So that you can get the same y value. So when you say, oh, my new x needs to be 3 less, that means shift to where? To the left, 3 units. So step 1, you just graph the fundamental function, natural log x, and step 2, you shift it to the left, 3 units. Okay? And make it simple. Well, at least you know this. Okay. So, how do you graph natural log x? For sure, when x equal to 1, it is 0, right? We all know that. Okay? And when x equals to e, it will be 1. What is e? E is about 2.7, approximately. So e is here. So when it is e, it will be 1. Right? It is an increasing function like that. This is y equals to natural log x. And then you shift to where? To the left, 3 units. So every point will be shifted, right? So you choose some representative points so you can know the shape. So first of all, this 1, 0 point is going to be shifted to the left. 1, 2, 3 will be here. And obviously, the vertical asymptote is also shifted, right? This y-axis was the asymptote. It approached to it, but not touching it, right? So now, how about this e? It's also shift 3 units. So it's the same as this is your new 1, 2, 2.7 will be here. So this also shifted. Okay, this is negative 2, right? Negative 1, 0. Okay? This will be your graph, natural log x plus 3. Is that okay? All right, any more? Okay, the dotted line. Remember, the natural log has this y-axis as its vertical asymptote. Means what? It's getting closer and closer and closer to this line, right? So the same thing when you shift it, this graph is going to get closer and closer to which line? To this dashed line, and this dashed line is also shifted from this y-axis. This y-axis was shifted 1, 2, 3 units to the left. Is that okay? All right. Now, some of you say, well, Dr. Chen, what about this 2x? Okay, remember, now you have the 2 in front of x, so the impact is also horizontally, okay? I said it already that I'm not going to emphasize on this in this class, but we learn, okay, the 2 in front of it, so it's like what? Oh, originally it was x. Now I multiply by 2, so my new value only need to be half, right? Okay, so you are what? Shrinking horizontally. And let me tell you, I will not test you those. So for it's learning, but we don't test you, okay? Let me tell you, it's going to be if you have a 2 in front, then the x will be half. So if it's -2, it will become -1. Okay? If it's here, it will become half. So it means it's shrinked. Okay? You will have horizontal shrinking by a factor of 2. So all the x values will be halved. So -2 become -1. Here it was a -3, so the asymptote line will become x equal to -1/2. Okay, and this is going to be like that. Is that okay? It's a shrinking. But again, I said already, so this red curve, let me say, this red curve is y equals to natural log 2x plus 3. So that is your step 3. Step 3, shrink or compress. Let's say compress horizontally by a factor 2. Then you will get y equals to natural log 2x plus 3. Everything the same except the x become 2x. Is that okay? All right. The domain and the range. All right. So what is a domain? The domain is what? Okay, let me put this back, right? Because this is the original problem. The domain will be what? All the value of x such that 2x plus 3 needs to be greater than 0, right? Okay? And x is a real number. And so what is that? That is x greater than -3 over 2, right? X is a real number. You can write it symbolically this way. And you can write in interval notation as -3 over 2 to infinity. Yeah? So you can see all this red curve, okay, it's what? Starting -1/2, right? Now, what is the range? Yes, the range will be all real numbers. Thank you. What is what? The vertical asymptote? It will be x equals to, vertical asymptote is a line. So you need to give an equation. Okay? It's x equal to -3/2, right? It's this dashed line that it approached to. Is that okay? Okay. So write it on it with a red pen or marker, so make sure that you review it later. Now let's do this factoring. That factoring (64x to the 5th minus 4xy squared minus 24xy minus 36). Okay. How many terms, my friend? 4 terms. Wow, there are 4 terms. So first step is you try to find greatest common factor. Do they have greatest common factor? 4x. So let me factor out 4x. So after you factor out 4x, what do you have? You get 16x to the 4th. And how about here? Minus y squared minus 6y minus 9. Awesome. Okay? Now, so this is a factorization form, but are we done? No. Not yet. Okay, can you tell me? What can we do further? Well, there are 4 terms. So a lot of us say, let's group using the grouping method, but then how you group it, okay? You have to be careful. So what did you do?
I factored out y squared minus 6y and 9.
She tried to group these 3 terms. Okay? I think some of you have tried grouping these 2 because you see, oh, maybe it's a difference of squares. Let me make it. However, it won't work. It will not work. Okay? I can show you. If some of you try and say, let me group these 2 terms, then you will get, I need a, excuse me. If you try to factor these 2 first, what would happen? If you have 16x to the 4th minus y squared grouped together, and then negative 6y minus 9 grouped together, you go nowhere. Because this, you get what? 4x squared plus y times 4x squared minus y. Okay? And how about here? Here you get negative 3 as your common factor. Then you get 2y minus 3. Okay? Look at this. Look at this. Is there any way there are 2 big terms, but do they have anything in common? No. So what do you conclude? You cannot do this way. Okay? You don't do this way. This is the wrong grouping. Well, this is a good try. This is a good try. All of you should know about this trial. It's not going to work. So we have to find some other way to group them. And these 3 terms, if you are good in recognizing it's a complete square, oh, is it? Yes, they all have negative sign. If you factor out negative sign, it will be y squared plus 6y plus 9. And that is a complete square of what? Y plus 3. So now this is a square, and that is a square. So it's a difference of squares. Is that clear to you? So the right way should be, okay, you write this down. You say 16 is 4 squared. So the first term is this square minus, okay, now it will become what? Y plus 3 squared. Am I too fast for you? Is that okay? Some of you may not feel, okay, let me do one more step. I factor out negative, so I get this. Okay, I factor out the negative sign for these 3 terms. So it's minus this, right? So you get 4x squared minus y plus 3 squared. So now this becomes a difference of squares. So you can say, you can factor as what? This plus that times this minus that, right? So the answer will be 4x squared plus y plus 3 times what? 4x squared minus y minus 3. Okay? Now you can box it. There's no more you can do. Does it make sense? Okay. You will have this kind of problem. So let's go back and review. What do we do first? You factor out what? The greatest common factor, right? And then you try to do the right grouping. And this is the right grouping. You need to group these three terms. And you recognize these three terms give you a complete square. Is that okay now? Okay? Yes. Good. So now we can erase this. What else? Yes?
You gave that problem twice.
Okay, that's okay. Then do twice. No. Yeah. All right. Now, can we do what? 8e? Oh, here. 8e. Yes, sure. Okay. Let me put here. Doesn't go down? Okay. Oh, do you see that? Wow. The projector has some problem. Okay, let me do it on the board instead. Okay. Oh, it's coming. All right, so the AE how many terms? How many terms? 2. It's a similar problem like that one. If you know how to do that problem, you will be able to do this problem. The first step is what? To factor out. Factor out what? 7 is common, right? Greatest common factor. Is 7 common? Yes. What else? B. Do you see that? Can you see?
Yes.
Okay. So now I can do this. So after you factor out 7 and B, you will see it's a difference of what? Cube. It's a difference of cube. So that is the practice for all of you. The first step is not jump into distributed or factoring it. You have to find, do we have a greatest common factor? Okay? Do we have a greatest common factor? Would you like to bring the treats tomorrow? What? Don't use that. Okay? I have no. Okay. All right. Anybody would like to continue? And tell me what would you do? That's AE, right? You have 7, A minus 5, cube, B minus 56, B to the power 4. Yeah? You know there are 2 terms. 1, 2. What is in common? Alberto? 7b. All right. So after I factor out 7b, the first term will have what? A minus 5 cube left. What about the second term? Minus 8b cube. You put the parentheses. Is that okay? And then what? This is the difference of cube, right? So you need to review. Review. What is the difference of cube? If you have x cubed minus y cubed, you can factor it as what? Say out loud. X minus y times x squared plus xy plus y squared. Okay? All right, so what do you have? You have 7b times, this is your x, and what is your b? What is your y? It will be 2b, right? Because what is 8? 8 is 2 cubed. Am I correct? Okay, so let me write one more time. Maybe that will be better for you. You try to write it in a form that is a difference of cubes. Is that okay? So now 7b times what? This is your x, and that is your y. Yeah? Do you see that? So you get a minus 5, and then minus 2b, right? X minus y, times what? The square of a minus 5, and then plus a minus 5 times 2b plus 2b squared. Are you with me? Is that okay now? And then,
No, I'm a little bit.
okay, a little bit.
Yeah, can you go back a little bit?
Okay, let's go back to here. Okay, this is x cubed minus y cubed, right? We can factor it using difference of cubes. So that is x, which is a minus 5, minus y, which is 2b. And then times x squared. What is x? A minus 5. The whole x squared. So you need to put the parentheses square. Is that okay? And then plus x times y. So x is a minus 5 times y is 2b. Is that okay? Okay. So far, so good? How do you simplify it? So let's do. It's a minus 5 minus 2b. How about here? What is a minus 5 squared all together? What is that? A squared minus 10a plus 25. Awesome. You are awesome. Okay? Don't forget about this middle term. And then continue. You have plus 2ab and then minus 10b, right? And then plus 4b squared. Any term that we can combine? No. Then we'll just leave it there. Is that okay? Sometimes you do have terms that you can combine, but not for this problem. Okay? All right. Any more? It's again a log problem, so I will choose this one. Okay, this is a log problem. 1/3 of log to the base 7a minus 5 log to the base 7b minus 4 log to the base 7c. And we would like to write it. Write the expression as a single log, right? How many logs we have right now? How many? 3. Okay? Okay. And they all have coefficients, right? This coefficient is 1/3. This coefficient is -5. And that coefficient is -4. Remember what we say? Okay, we would like to make sure every log they have coefficient 1. So let's use the power rule reversely. Can I make this coefficient back? Yeah? Okay, so what do you have? Log to the base 7, a to the power 1/3, right? Okay, for this coefficient, -5, I can also do that, right? So you will include this negative sign, okay? So that you will make it as a sum. log to the base 7 b to the power negative 5. Does it make sense to you guys? Okay. Now, how about the third term? The coefficient is negative 4. Again, we use the power rule to put this coefficient to the exponent part. So you will have what? A sum of log to the base 7 c to the power negative 4. Is that okay? Now, this is a sum of 3 logs, right? You have 3 logs. They are sum. So now you can make it as a single log of product, right? So now you're going to multiply a to the power 1/3 times b to the power negative 5 times c to the power negative 4. Because it's a sum. So when it is a sum, it's easy. It becomes log of a product. Remember?
The negative always goes with it.
Because I make the negative sign go to the exponent, right? So now you have a sum of logs. You just multiply because that is what is that rule? Log of a product, right? Remember, is sum of 2 logs. You see that? This is the rule. So when you have a sum of 2 logs, you can write it as a single log of its product. Is that okay? Now, what is this? What is this? What is this? Well, let's try. It is a, which is 1/3, or you want to write it as a cube root, okay? But b to the negative 5, so it will, go down to the denominator. C to the negative 4, go down to the denominator. Is that okay? Yeah? You're taking the reciprocal. Is it clear? Which part you need more explanation? On the last part. Okay. What is b to the negative 5? b to the negative 5, you have to take what? Reciprocal. So become 1 over b to the 5th. Right? So when you have negative exponent, right, you need to take reciprocal. So it will go from numerator to denominator. So this is something you want to also keep in mind. All right? So b to the negative 5 is what? 1 over b to the 5th. And you will have this kind of problem on the exam. All the problems that I quiz you are those representative problems. Okay?
But can we keep the a as
To the power 1/3?
Yeah.
Yes, you may. Yes, you may. You can keep as an exponential form. Yes, you may. As long as it's all positive exponent. Okay? All right. Now, we'll do this problem. Number 5, it is about functions. Okay? It's a function understanding.
I can't see it.
Can you see it now? It's a function understanding. Oh, maybe it looks like it sees through, huh? Let me change another paper. Okay. Okay. Given a function that is log to the base 3 x plus 4 minus 5. Is it one-to-one function?
Yes.
Yes. Why?
Because it has a horizontal line.
Okay.
Passes a horizontal line.
Okay. How do you know? So you will say, you're right. You are actually very good. Okay. Because what? Can you tell me?
Because of the slopes are and the points don't.
There's no slopes. This is a logarithm. So I think you probably would like to say it's increasing.
It's increasing. Yes.
Yeah. Okay. I think that's what you meant, right? It's increasing. Okay. Yes, because it is an increasing function. Okay? It has the same shape of the graph of y equal to log to the base 3x. Has the same shape. Okay? With shifting. Does it make sense? To graph this function, you will start with the fundamental function, log to the base 3 of x, and then you shift to the left 4 units, and then you shift down how many units? 5 units, right? Okay? And this is increasing, right? Because its base is what? It's greater than 1. Yeah? The base is greater than 1. Okay? This base is greater than 1, right? So it's increasing. For log, all the functions has this shape, right? Yeah? This is the shape of the log. But you shift to the left. Shift to the left 4 units. How do you shift? You shift it to the left 4 units. And shift it down 5 units. Okay? So by shifting, you are not changing the shape. It's still increasing, right? So it is 1 to 1. Okay? Does it make sense? It is increasing, so we pass horizontal line test, right?
Can we just say that instead of all that?
When you say it passed a horizontal line test, why? Then you have to graph it. So if you want to say it passed a horizontal line test, because you have the graph already, right? Okay, so then if you want to say it passes horizontal line test, then you need to graph this function. You know what I'm saying? So that, people see the graph. But if you don't graph it, a lot of people try to avoid graphing it, and when you say, you know what, it's the same shape as this fundamental function. And we know very well about this fundamental function. This fundamental function with the base 3 is increasing. So you don't need to graph. Save your time on graph. Yeah, but you're right. You can say that. Okay? It passes the horizontal line test. Okay, now, what about the domain? The domain is what? Domain is whatever number of x making x plus 4 to be positive. Yes, great. So it's what? It's all the x value making x plus 4 positive. And x is a real number. And that is x greater than negative 4, right? And in the interval notation will be what? Negative 4 to infinity. Sorry? Minus 5 is shifting down, right? This is a graph. This is a graph going everywhere. And you shift down 5 units, the range still, it's not changing the, this 5 is not changing your domain. This 5 is changing your y, your y value. But your y value right now is everywhere. So when you shift down, still everywhere. Okay? So this is not changing your domain. The negative 5 not changing your domain. Only this 4 will make change of your domain. Is that okay? So, yes.
In our answer, just put the top set notation. You want us to specify those 3.
We will tell you, you need to give a set notation, interval notation, and you will graph it. So you do need to graph it, negative 4, and it is greater than negative 4, like this. Okay? This is the interval notation, and that is a set notation. interval notation will be a must. You must know how to do your answer in interval notation. Okay? But that is coming from your understanding of this, right? Okay? What is a range? You tell me. What is a range? What is a range? Look, what is a range? Yes, all real number. When you shift it down, still all real number, right? So it will be from negative infinity to infinity. Okay? Because it's the same shape as this fundamental function, right? Okay? All right. I hope this is okay to all of you. I will leave this for a little while. So far so good? The factoring so far is a little bit involved because you have difference of cubes, sum of cubes, so difference of squares, so you feel like, oh, I have to recognize some pattern. In the chapter 5, the factoring is going to be much, much simpler. So you will feel so easy now, okay? So let's look at chapter 5. Okay. Let's look at chapter 5. What is the topic of chapter 5? It is about rational expressions. What is a rational expression? Can anybody tell me after you have done your pre-reading? A rational expression is, can you look at that page? Everybody? I will send this PowerPoint to all of you. So if you don't take notes for today's, it's okay, because all of these are very simple factorization for simplifying rational expressions. Are you ready? Yes? Yes. Okay, so we're going to talk about, oh, excuse me. Can you see? Is that clear to you? Yeah? Okay. All right. So we are going to talk about rational expressions and rational functions. Okay. And first, we are going to learn how to multiply and how to divide rational expressions. Okay. And these are objectives. So now you have to know domain and range. So again, what is a domain? What is a range, right? Second, you need to simplify it. Okay. So that you divide out all those common factors. And then you need to learn how to multiply and how to divide them, okay? And work with some rational functions. All right, so what is a rational expression? It is what? The quotient of two polynomials, like this. We do have that, right? Okay, look at the first one. It's simpler. All right, so if I ask you, what is the domain for this expression? Can you tell me? It is? Cannot be negative 5. So it will be all real numbers except negative 5. So you know how to write it in interval notation? It will be negative infinity to negative 5 union negative 5 to infinity, right? Are you with me? Okay, let me write it down here. We will see that, okay? Let's continue. You will see that. Okay. Now, how do we reduce to the lowest term? How do we simplify it? You would like to see whether you have common factors. Okay, now look at this one. Do we have common factor from the numerator and denominator right now? Can I divide this 4 with that 12? Can I? No. Why not? Because they are adding and subtracting. It's not multiplying, right? If they are in factorization form, then you can divide out common factor, but it's not yet. So in order for you to simplify this expression, you have to factor the denominator. You have to factor the numerator and see whether they have common factor. Is that clear? Okay? you cannot just divide this out because it's not a factor. See, this is a minus sign, plus sign. They are just terms. They are not factors. Does it make sense to you guys? Okay? You have to write it in product form. What times what? So you can look at the common factor. So, how to find the domain for this expression? Okay, so somebody just say, okay, we don't want the denominator to be 0. So let me find out what will make the denominator 0. So you set denominator equal to 0. What will make it equal to 0? You factor it. Oh, so what is the answer? It's what? Either x plus 2 equal to 0 or x minus 4 equal to 0. Is that right? So means what? X equals to negative 2 or x equal to 4. So how do you write it in the set notation? You say the domain is this set. All the x not equal to negative 2, x not equal to negative 4. Okay, so how do you write it in interval notation? On the number line, you are going to see oh, sorry, there. Oh, good. Number negative 2 need to be taken away. Number 4 need to be taken away. So what is the set of points that I can use as domain? It will be either all the points here or all the points in between or all the points to its right. So how do you write this domain in interval notation? Negative infinity to negative 2, union, thank you, negative 2 to 4, and then union, thank you, 4 to infinity. Yes, you will have this kind of problem on your exam. Discussing domain. How do you find it? Find out where will make the denominator equal to 0. Kick them out. Oh, so on the graph, it's very clear. This is a graph of the domain. This is the interval notation for the domain. Is that okay? All right. How do you simplify? Uh-oh. How do I simplify it? Can I divide 10 with the 2? Oh, thank you. I cannot just divide that. I have to factor. So let me factor the numerator. What can you factor out for the numerator? 5. Thank you. Okay, now you can see this is a product, right? 5 is a factor. X plus 2 is a factor. X plus 2 is a whole factor. This factor and that factor are common, right? So now you can divide out what factor?
Then we can cancel it out. We cancel it.
Yeah, we say divide out. We don't say cancel. We say divide out. Okay? So you divide out. Do you see that? You divide out common factor. You divide it out. Okay? Because this is a product. 5 times this. This is a common factor. Is that okay? All right. What is the answer? 5. Thank you. Okay, now how do we multiply rational expressions? Well, it will go to the simple knowledge how you multiply two fractions. How you multiply two fractions. How do you multiply them? How do you multiply them? The numerator times the numerator, and then the denominator times the denominator, right? That's pre-algebra. The same way to expressions. Okay, how do you simplify it? So again, when we want to simplify, you need to do what first? Factor, right? You want to factor the numerator and factor the denominator. Does it make sense to you guys? Okay? And then, you know what? I probably would like to do a little bit differently this time. Okay. I want to go back. I need suggestion. Lena, what would you do to factor the numerator? Factor out the 2. Okay, so you know what? I'm going to follow what you say. You factor out the 2. And how about the denominator? You factor out what? X. All right. So this is what you can get, right? Okay, I factor out negative 2. I factor out 2. Here. Okay, we factor out 2 for the numerator. Now, oh, you know what? I could go up again. Okay, what's next? What do you do next? You see that? This is 4x minus 3. What is this? 3 minus 4x. What is 4x minus 3? How does it relate to 3 minus 4x? They are opposite. Thank you. So you can divide either 4x minus 3, or 3 minus 4x, but then they are going to have a negative 1 factor. So in order for you to see that, can you tell me how you do that? Can you factor, okay, say that you factor negative 1 from the numerator. Then it's going to become negative 2 times 3 minus 4x. Is that okay? Are you with me? Yes? Or someone would like to factor out negative 1 from the denominator. Then this will become 4x minus 3. Which way you want to do? The denominator. The easy one. Okay, so you know what? I'm going to go with you. What do you say here? Okay. We are going to factor out negative 1. Right? Are you with me? There are different ways to do it. 4x minus 3. Okay, I factor out 2 here, I get this. I factor out negative x here, and I get that, right? And then I can divide out 4x minus 3 with 4x minus 3. Do you see that? Yes? Yes or no? Yes. So that's what you get. Is that okay? Okay. Anyway, the whole idea for this problem is for you to recognize 4x minus 3 and 3 minus 4x, they differ by a negative 1 factor. Is that okay? Yeah. Now, how do we multiply rational expressions? Okay. Let's multiply it. Wow. Let's distribute 7x plus 7 times x squared minus x minus 20. How many of you can do it within 1 hour? It's going to take a long time, huh? Do we do that way? No. So what would you do? Factor. Yes, because I'm going to multiply, but then I'm going to simplify. So I would like to factor. Okay? Factor, factor first. Okay, so this is how you do it. You factor each numerator and each denominator. So this you have 7, right, as a common factor. And this you can factor as x minus 5 times x plus 4. Is it okay so far? And then for 7, x squared minus 42x minus 49. 7 is common, so you can factor out 7. Does it make sense so far? See, this factorization is so easy for you, right? Compared with the previous one. All right, so I know this is an easy chapter for all of you. Now, what's next? Cross. Divide out, yes. Okay. Before you divide out, can I ask you, is anywhere I can still factor? Where? Oh, the denominator. Can I factor this? You will become what? X minus 7 times x plus 1. See that? You factor it again. Oh, no. After you factor again, you see more common factors, right? So no rushing. Well, even you divide out earlier, later you still want to ask yourself, can I factor more? Is that okay? So now what can you do? You can divide x plus 4 with this x plus 4. Any more? X plus 1 with the x plus 1. Any more? 7 with the 7. Okay. So, see that? Great job. So, what is the answer? X minus 5 over x minus 7. Is that okay? Not hard, right? So I told you this section is straightforward. You will have this PowerPoint I'm going to upload to your Canvas, okay? Dividing the rational expressions. How do you divide it? Well, it's the same as how you divide numbers. How do you divide numbers? Hey, how do you divide this? It's A over B divided by C over D. So dividing can be rewrite as multiplication of its what? Reciprocal. So that's how you do it. The same way for expression. How do we divide this? Okay, you say, no problem. That means the numerator divides the denominator. Am I correct? But then when you divide this, you can write it as a multiplying its reciprocal, right? Okay. What do you see now? Do you multiply quickly? Say, oh, you know what? I'm going to multiply, distribute. Do you do that? No. You first find whether they have common factor. Do they? Yes. This as a whole is a factor common to this. And then x is common to x, right? 2 can divide into 4. So what do you get? The answer is 2, right? Okay. So far, so good? Now, if you have a function, say, hey, my function r is p over q. Well, then just do that. So if somebody tell you, oh, that is my function f, this is my function g, can you find f over g? Then you say, no problem. I just do what you say. Okay, f divided by g is f multiply the inverse of g, the reciprocal of g, right? Do you see that? You divide by g, but what is g? G is that. You divide by that means you multiply its reciprocal. Yeah? Okay. I will pause here. Any question for this step? No. Is that okay? Pretty cool. All right. Now, piece of cake for you, right? Then you say, what to do? What to do? It's multiplying, right? It's already multiplying. What do you need to factor it? Right? Just factor. It's piece of cake for you. Is that piece of cake for you? Can you tell me how you factor this? It is 2x, the whole thing squared. This is 3 squared, right? 2 and 3 is 6. Double it is 12. So this is a complete square of 2x plus 3. So this is 2x plus 3 squared. What about this? This is 3 squared. So this is 2 squared, right? So this is a difference of square. So it's what? 2x plus 3 times 2x minus 3. How about this? 3 will be factored out. So you get 3 times 2x minus 3. Do you see that? I told you it's piece of cake. Is that piece of cake? This kind of factoring is much simpler than this morning's discussion, right? You still need to use them. Difference of cube, difference of square, and so forth. So now how do I simplify? This will divide out with that. This will divide out with that, and so forth. Okay, so that's it. The answer will be 1 over 3 times 2x plus 3. And x cannot be negative 3 over 2. Does it make sense? Okay? All right. So I will leave this PowerPoint on Canvas. And let me tell you, 5.2 is about, can I have all of you look at 5.2? Okay. 5.2. Adding and subtracting. Okay? So based on the same idea, adding and subtracting fractions. You have learned your pre-algebra. You need to find what? Common denominator. The same thing. So what do you tell me? You say, Dr. Chan, you don't need to lecture now. We just need to find a common denominator and then do it. So this chapter 5 is very straightforward. Okay? It's just like what you learn in fractions. Today's homework, okay? I want you to finish all your quizzes. I give you more time. You just need to finish all the quizzes and you bring it tomorrow. Does it do good to you? Extra. Which one?
Which ones are you talking about? My math class or the?
No. I mean the quiz. The quiz that you ask me questions. I want to give all of you a little bit more time, okay? And you bring it tomorrow, okay? And this is finish all your quiz, okay? Now, that's 2 parts, right? There's a 1 and 2, right? And then you have the homework on 5.1. And actually, for all of you, you know the concept right now. You have to know, I am reviewing. This is a reviewing part for your beginning algebra. You learned this in the previously. But I want to do a good review. You can continue. You can continue to 5.2, no problem. Because it's just finding the least common denominator and add them. But I'm not pushing you. I want you to do a good job. But these 2 is add, subtract, multiply, divide, all the rational expressions. Does it make sense to you? Okay? All right. So you need to pick up your homework before you go. Now, next week is the big exam. But I would like to help you so that you get prepared. You are going to have, so today, I didn't give you a big quiz, well, yesterday. I need to give you a big quiz for the log and the factoring, okay? So expect that. And then this Friday, I will give you a quiz on all those rational, and we are going to start radical again because radical is new. Rational is something you have learned before. So this Friday, you are going to have a big quiz on the rational and radical. So I can prepare you for next week's exam. Would that be good to you? Okay? You need to keep up with your homework. How many of you need extra help like tutoring? Come to me, okay? I will try to schedule you with a group quiz. So pick up your homework here, everybody, okay? And tell me, leave your name here for you to receive a tutoring, extra tutoring. Okay, leave your name here. Oh yeah, I have a pen. So tomorrow and Friday you have big quizzes.
Where's
Hey,
pathways? And then we
pathway.
Yeah.
I need, oh,
Hit the, yeah.
okay, I need to talk to both of you. From the pathway? Okay.
Yeah.
Okay, it's going to be next week because you need to take the midterm in order for me to tell you where you are.
It just says here the
This is until
attendance
the-
attitude, and that's it. It's like they don't need any test or anything.
Oh, you don't need that. Attendance, huh? I need you to do more, keep up with the homework and, you know, in the class, not to look at your... May I?
Yeah.
It's going to help you to learn, right? Okay, so can I get some help reminding him?
Okay.
Remind me every day.
Buddy,
I will.
tell him that, sorry. Tell him, you don't need to bring the tree, just not to look at it.
All right.
Okay.
Okay, cool. I will give you. So you get help from there. Okay, the first one will be Thursday. So I'm going to give a Thursday review. So how many of you can is 4 to 5 good to all of you? This Thursday, either before the class, 9 to 9:40, okay, or afternoon from 4 to 5. Before.
Yeah.
Morning. No, for tomorrow.
But this is for tutoring or?
For tutoring. It's for tutoring.
Yeah.
Yeah, okay. So tomorrow is Thursday. Okay? tomorrow morning.
What time? I mean, where? In this class? Or in
No, in my office.
Okay, good.
Okay, so tomorrow morning will be a extra tutoring help, okay? I'm going to do it, okay? It will be in my office.
Okay.
Will be in my office. Would that be good to all of you?
Yeah.
What time?
The next 2 days are quizzes, right?
9. Okay? Because maybe some people need a one-to-one consultation, but from 9 to 9:40, I will do the group.
Okay.
Would that be good?
Yeah.
Okay. R322I, ice cream. Ice cream? 322. Okay, all right.
Professor, for the homework, you meaning 5.1 and 5.2, all the problems or specific?
It's on Canvas. Yeah, it will be my math lab, and textbook. Okay, it's on the Canvas. All right, as before, always like that.